I got amended this problem a little bit from the original. So an airplane's instruments say it is flying directly east at 300 miles per hour, but it is really heading south 60 degrees east with a ground speed of 330 miles per hour. What is the speed and direction of the wind? And there's a little hint, we need to use vector subtraction on this one, because its real heading is this, with this ground speed, and that's the sum of two vectors. One is what the plane is doing, which thinks it's flying directly east at 300 miles per hour, and the other is what the wind is doing. So the missing piece is the wind. So we need to use vector subtraction to find that. So here we have it. We've got the airplane thinking it's flying due east at 300 miles per hour, but instead it's flying south 60 degrees east, which would really be 30 degrees south of that, of east. So this is a 30-degree angle, and the ground speed is 330. And so therefore we need to know the speed and direction of the wind. Well, the speed of the wind we can get pretty easily because of the law of, again, we got two sides in the included angle. We need the third side. That's side angle side, and we would use the law of cosines. So according to that, the wind speed squared would be equal to 300 squared plus 330 squared minus 2 times 300 times 330 times cosine of 30 degrees, but I can't do that, so I'll say pi over 6, and that should be good. And so if I simplify this, I get this wonderful answer, and if I actually want to do even better, I'll evaluate it with a floating point, so I get a decimal approximation. And that's, of course, the square of the wind speed, so therefore the wind is the square root of this. And this is just calculator stuff here, and we can evaluate that with the floating point as well. And so, wow, that is one fast wind. Kind of knew it was going to be fast wind. So 165.61 we'll call it. So when I go back to my picture, this is 165.61, let's say. I thought I was going to be typing there. I guess I didn't. 165.61. So hurricane force wind here, definitely. See what I give up for making a problem up. So now the question is, what is the direction of the wind? Okay, now we've got a little bit of a problem. If we could find this angle and subtract 90 degrees, it would be south, whatever that little smidgen that's left, degrees east. It would be, the wind would be 165.61 miles per hour south, smidgen east. But that means I need this angle here. I don't know what else to call it, so let me call it something. I'll call it angle. How about a nice Greek letter? Angle theta. Huh? So I can't get an angle theta very easily, so I'll call it angle. I don't want to call it angle x. How about if we just call it angle A? Oh, I thought it was alphabetical there. Angle A, there we go. And so here's our angle A. And how do we find this angle A? Well, probably a couple things would come to mind, but like in the easiest possible way would be to use the law of sines. So in that case, sine of A is to 330 as sine of 30 is to 165.61. So back from my picture. Sine of A, whoops, sorry, is to 330 as, I gotta look at my picture again. Sine of A is to 330 as sine of 30 is to the wind. So, but I can't use 30, I've got to use pi over 6 divided by the wind speed, which I'm not going to round this off if I don't have to. I'll just copy it and paste it right in there, and that way I won't be doing any harm. So when I go to solve for A, this should work. I got A as 1.484, blah, 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 blah. I don't know if you see the problem with that. Does anyone see a problem with that? Please tell me. Yes, I see a problem with that. Of course, I could have multiplied both sides by 330, and that would have given me the sine of A. But I solved it for A. Now, does anyone see what's weird about that? I mean, we know we don't have a 1-degree angle. And the answer is, oh, of course, I know what's wrong about that. Your software is always in radians. So to convert that, I have to multiply it by 180 divided by pi, because I want to get this in terms of the problem we're given, which is degrees. So, and let me give a decimal approximation of that. So about, oh, that's not good. That's not good. That is not good. Does anyone see why that is not good? Because we thought surely our angle would be more than 90 degrees. Based on the picture, it would have to be. And let me remind you about a very important thing of the law of sines. There is such a thing as an ambiguous case. So the angle isn't 85 degrees. It's in fact 180 minus 85 degrees. So that angle is really, let's simplify that, 94.922 degrees. All right. Now we're getting somewhere, but that's still not the angle we need. The direction, the heading is south. 4.9. What happened to my decimal point? I'm trying to hit a decimal point, it's not giving me that. Alright, it's going to be hard to write this then, but bear with me. With the software south, 4.9228 degrees east. That is the direction of the wind, almost coming from the north. That's the direction the wind is blowing. Okay, we've got that one linked. Nice refresher for the law of sines in the ambiguous case, I hope.